Hello Year 9, and this is the second part of Standard Algebra NAPLAN. Charlie wrote down the first three numbers in a pattern, 4.3, 3.6, 2.9. Now what is the rule to find the next number in this pattern? As I look at these numbers, I noticed one thing, that the numbers are actually decreasing from 4 to 2.9. So in that case, we definitely will not be able to use B because there's an increase, and D because we're talking about an increase. So we've got two answers that we've got to decide on, and that's a decrease by 0.7 or a decrease by 0.9. And so if we subtract 3.6 from 4.3, we'll get a decrease of 0.7. And we can highlight that it's A. First, you're told that the circle with the cross is worth 3, and also that the triangle is worth 4. And now you're also given this equation here in terms of these objects, and this is what it looks like. You want to find out what that diamond is, so I'm just going to color it red. But you do know what the circle with a cross is, it's 3, and you know what the triangle is. So now that I've substituted what we know, we've got 3 plus the diamond, which is equal to 4 plus 4. And now 4 plus 4 equals 8, so our equation now is simplified. Well, we can work that out both ways. We can just substitute 2 in here and say 3 plus 2 is 5, so it's not 8. What about 3? 3 plus 3 is 6, and that's not 8. What about 4? 3 plus 4 is 7, so that's not 8. 5 plus 3 is 8. So we did that by just guessing. Now we can do this properly, and that is by rewriting that equation into this form, and that is, well, that makes the diamond equal to 5, just as we said before. So we can highlight D for 5. So Claire wrote down the first 5 numbers in a pattern. So in your head you probably go through it, okay, well, they are not all odd, they are not all even. What's similar about them? And it comes to you that they all might be divided by 3. 3 into 3 goes once, 3 into 6 goes twice, 3 into 9 goes 3 times, 3 into 12 goes 4 times, and 3 into 15 goes 5 times. So they are multiples of 3. The next question, the question that they are asking you is, which is not a number in this pattern? I've got 36, 45, 67, and 99. Are any of these numbers, or which numbers are divisible by 3 and which are not divisible by 3? If it's divisible by 3, 36 will be divisible by 3. 45 will also be divisible by 3. But 67 cannot be divisible by 3. That's absolutely out of the question. And 99 is divisible by 3. So I guess the number that is not going to be part of this pattern is C, which is 67. So which rule connects X and Y? We need to start by substituting 1 into each equation of A, B, C, and D, and finding if it turns out to be 3. Okay, let's start with A, and let's substitute 1 here. So 1 plus 2 is 3. And you are tempted to say that this is the rule that connects X and Y, and you would be wrong, because it may work for one set of numbers but not for the second set of numbers. So let's just try 2, for instance. If I substitute 2 in here, then 2 plus 2 is 4. It's not 7. So this is not one of the rules. I'll cross it out straight away. Let's go for B. Let's start with 1 again. Now, so let's go through this one first of all anyway. X is 1. 1 times 3 is 3. And let's go for 2. 2 times 3 is 6. So it's not that one either. cross it out. Go to C now. Substitute 1. 1 times 4 is 4. 4 take away 1 is 3. That works. What about 2? 2 times 4 is 8. 8 take away 1 is 7. Oh, that works too. Let's go for 3. 3 times 4 is 12. 12 take away 1 is 11. Oh my gosh, we are heading in the right direction. 4 times 4 is 16, take away 1 is 15, and 5 times 4 is 20, take away 1. So this is it. We don't really need to go any further because there's only one rule. So we will just color in C. We're done. So you can see that algebra is full of pattern questions. Here Kevin wrote down the first 5 numbers in a pattern. Now I must stress that the more of these questions that you do, the more you'll be able to recognize different patterns. This particular pattern, when I look at it, it's got a 2 and a 7, and then again a 2 and a 7, and again a 2, and I suspect that the next number, the way that it looks, is going to be 27, and then it's going to be 32 and 37 and so on. When you examine the answers to these questions, you'll find that they end in 7, 2, 7 and 2 here, so they all could be applicable, but you want the 21st number in this pattern. You can go about it, I guess, 2 ways. One is the long way, and just start counting and writing them out until you come to the 21st number, or see if there is a rule to it. Another pattern that I can see is that each number differs by 5. I don't know whether that is going to be helpful or not, but that's what is happening. Now, first of all, if we start with number 1, this is number 1, this is the second number, this is the third number, this is the fourth number, this is the fifth and sixth and seventh and so on, okay? To obtain my first number, which is 2, I might have multiplied 1, because it's the first term, by 5, and take away 3, and that would give me 2. Which is my first number. Now let's look at the second number. It's 2, and again I'll multiply it by 5, take away 3, and I'll get 7. I'm beginning to have a pattern here to my numbers. So now I look at the third number, and that is going to be 3 times 5 minus 3, and this will give me 12. So my 21st number, in that case, using this particular rule, we can write 21 times 5 minus 3 and find out what it is. I get 102. So that means that our answer is B. It may have been easier for you just to continue working out the 21st number, or to find the rule. Letters again, letters representing numbers. A will represent 6 and B will represent 5. And what's the value of AB minus B? By substituting A and B for 6 and 5. For 6 times 5 minus 5, just work that out. It'll end up being 25. So I'll highlight D. Another pattern question where Kylie has written down the first 5 numbers and what is the 10th number in this pattern. Once again, I just have a look at them. They're not just odd, they're not just even numbers. So then I'll look at the difference between them, the difference between 2 and 5, and the difference between 5 and 8, and the difference between 8 and 11. And actually I noticed that each time it's just the difference of 3, which seems to be really simple because all we need to do is just keep on adding 3. Now the 10th number, if we start at this is being number 1, number 2, number 3, 4, 5. What we're just going to do is going to go and keep on adding the 6th, 7th, 8th, 9th, and finally the 10th number. So let's go for it. So 14 plus 3 will give me 17. And 17 plus 3 gives me 20. 20 plus 3 gives me 23. 23 plus 3 gives me 26. And 26 plus 3 gives it me 29. And that would be my 10th number. They would all be a difference of 3. And don't forget to write the answer in here and say that it's 29. This is a question which involves solving for x. We want to find out the value of x. So we need to move values like 1 and 2 out of the way. And the way to do this is to undo the operations that we have. Now remember that we always undo the addition and subtraction before multiplication and division. The last operation performed here was adding the 1, so we need to undo it by subtracting 1. We must do it from both sides, and so we'll be left with 2x plus 1 minus 1 disappears, and this will equal 25 take away 1, which will be 24. And now we apply the inverse operation for 2 multiplied by x, and that will be dividing it by 2. Again, do it to both sides, and by cancelling the 2 here and the 2 here, we just end up with the x value, so that now x becomes 24 over 2, which is 12. And we are able to highlight C. So Sam wrote out a pattern using symbols from the playing cards. And these 4 symbols repeat themselves throughout that pattern. So when we start counting the symbols, they'll start with 1, 2, 3, 4, and the spade will be the 4th one. We start again, but this time 5, 6, 7, 8, and so the spade will be 8. So if I wrote this down below, the spade will be 8, 12, 16, 20, and so on. Now we want the 50th symbol, so we can continue with that and say 24, 28, 32, any number that's divisible by 4. And the one about around the 50th would be 48, and then 52. So if 52 is going to be the spade, then 51 will be the clubs, and therefore 50 will be hearts. And so the 50th symbol will be B, the hearts. So Joan is making a pattern with matches. How many matches will be needed for the 5th shape? I would like to put it into a table with shape 1, shape 2. Now we need to count the matches. The first one is 1, 2, 3, 4, 5, 6. 6 matches for the first one. And for the second one, it'll be 12 take away 1, because that one is common to both. So we've got 11 matches here. And the third shape is made out of 3 domes, 3 lots of 6, which is 3 times 6 is 18, and 2 of the matches will be common to both. So 18 take away 2 means that there will be 16 matches. The 4th shape will therefore be 4 times 6. That means it's 24. and 3 matches will be common, so we'll have 21. Now, you might also notice that the difference from 6 to 11 is 5. From 11 to 16 is again 5. You're always adding 5, so I don't have to do any more working. I can just add 5 to this, and I know that I will get 26 matches for the 5th one. So we'll write the answer in 26. And that's all for the standard level. The next video will be one for intermediate level. It'll be a little bit harder, and as you can see, they're mainly patterns and rules.